Hello, I am Rolando Negra, lead author of the article Predicting Demand in Changing Environments, a review on the use of reinforcement learning in forecasting models, writing in conjunction with Dr. Miguel Angel Cano. I'm going to explain what this research consists of. These are the topics we will cover. Demand forecasting plays a very important role in today's business. Thanks to it, you can plan the resources needed for operation administration of supply chains and other company functions such as finance, human resources management, and marketing also require it to properly plan their activities. However, demand in many sectors such as electricity, telecommunication, transportation, and retail are very difficult to forecast due to the non-linearity and volatility of its behavior. In addition to the enormous number of possible explanatory variables which also change over time. Therefore, due to these complexities, in recent years, machine learning models have been proposed for this task. These vary in numbers and strategies, highlighting the use of deep learning and the construction of dynamic ensembles of heterogeneous models as outlined in the studies shown on the screen. A major potential problem with these algorithms, most of which are based on supervised learning, is concept drift. This means that over time, the relationship between the explanatory and explaining variables change. So the training set of this model stop representing reality and therefore the models lose precision. The author Gamma argued that truly adaptive forecasting model must have mechanisms for detecting and adapting concept drift. Precisely because of the latter, it is striking that in the previous literature review, no model based on reinforcement learning appears, given that in the machine learning paradigms, this is the only one that is in constantly learning from its environment and adapting to its change. Reinforcement learning is conspicuous by its absence. For this reason, the authors decided to undertake a literature review specifically focused on reinforcement learning applied to demand forecasting. The methodology used in the study was PRISMA methodology, was used to conduct the literature review. These were the research questions. The sources of information were the Scopus, Web of Science, and IEEE databases. The respective search string was the one shown in the screen. As an aid to the analysis of the articles and as a way to prevent to preventing the introduction of biases in classification of studies, automatic grouping of articles through hierarchical agglomerative clustering was used. Results. As a result of the selection of articles, 24 documents were included in the qualitative synthesis. The main criterion was that reinforcement learning was part of the forecasting model. In many discarded models, reinforcement learning was used for some tasks after the demand prediction, such as resources allocation. Documents of this type were discarded. Four main groups emerged from the automatic clustering: the policy grading group, the Q-learning group, the WQ network group, and the Q network group. We will now describe each of these groups. The policy grading group. This is a group use the DDPG to directly predict demand or to determine the most appropriate ways to integrate a base of predictor to tackle the variability of different time scales and the volatility of demand fluctuations, avoiding the limitation of Q-learning to handle unlimited state space. The Q-learning group use Q-learning algorithm for the dynamic selection of the best predictor, although it is also used for the integration of predictors using weighted weights to find a model that works in several scenarios and under changing situations. The Q network group use the DQN algorithms for different purposes within the forecasting process, such optimize hyperparameter and dynamically select the best predictor. The WQ network group use DDQN algorithms to identify similar consumer segments for forecasting purposes and for the dynamic selection of the best predictor. Recent questions, main question. How has reinforcement learning been used in the development of demand forecasting model in recent years? Reinforcement learning models have been used in four main ways: to predict demand directly, to dynamically select the best predictor, to integrate by means of weighted weights a set of base of predictors, and for hyperparameter optimization and other secondary tasks. What demand forecasting issues or challenges have been addressed with reinforcement learning? There are basically three: demand in highly changing situations, variability of different time scales, demand in highly complex situations. What reinforcement learning algorithms have been used for this purpose? They are Q-learning, deep Q network, double deep Q network, and deep deterministic policy grading. What metrics have been used to measure the performance of the proposed models? The vast majority of proposed models measures the accuracy of the forecast with one of the three classic metrics: mean absolute error, mean squared error, and root mean squared error. What is the performance of the new proposed models in relation to the established models? All proposed models report superior performance to the models taken as a reference. In which business sector have forecast models based on reinforcement learning being used more frequently? Most of the studies come from the electricity sector. Three articles focus on the transport sector, two on the telecommunications sector, another two on the heat energy sector, and only one on the semiconductors distribution sector. It is interesting to know that 23 of the 24 items come from the service sector, especially energy, while only one item comes from the trade sector. Proposed model. Although the model studied seek to adapt to the dynamic of demand, none of them show explicit mechanisms to detecting and adapting to concept drift. We therefore propose a new use of reinforcement learning for this purpose. The model is based in three basic elements: a memory mechanism based on a sliding window that forgets the oldest data and it remember the most recent data. Second, an algorithm that selects the best predictor from a pool of supervised machine learning predictors. And finally, reinforcement learning that monitors the errors generated by the predictors and learns to decide whether it is necessary to retrain the model with recent data in order to preserve their accuracy. Discussion. One of the most important use of reinforcement learning is direct demand forecasting, mainly using the DDPG algorithm to handle a continuous action space and state space of high dimensionality. However, this algorithm needs mechanisms to facilitate the convergence. A limitation of all these studies is their exclusive focus on DDPG algorithm. There are 17 other reinforcement learning algorithms capable to handle this condition. On the other hand, the most frequent use of reinforcement learning is for the dynamic selection of the best predictor from a pool of predictors. The majority propose the use of Q-learning for this purpose, keeping the state space for selection very simple. A diametrically opposite approach is followed with by proponents of DQN and DDQN. They allow to insert complex state space thanks to the use of neural network. The main limitation of all these selection models is again that they do not have any drift detection mechanism that indicates the need to update or retrieve the baseline predictor. Conclusion. Reinforcement learning has been used mainly for the selection of dynamic integration of the best predictor from a base of them to adapt to changing environments. Whereas forecasting in volatile and complex environment is the main issue addressed. The Q-learning, DQ-learning, DDQ learning, and DDPG are the most widely used algorithms. And that finally, the sector of electric power, thermal energy, transport, and telecommunication are the sectors where this type of forecast has been applied. Thank you very much.